We are presenting a novel, dual-modal optical tactile sensor capable of accurate sensing with high spatial resolution and high-speed sensing which is analogous to pain perception in animals. The sensor itself is inspired by a well-established tactile sensor known as the tactip. We have a compliant structure which deforms when stimulated. On the inside surface are several white markers. The deformation of this surface is recorded by a camera. Here we use a completely novel camera system which is taken from an optical computer mouse. This camera provides a full 30 by 30 pixel image, but also has a second mode of operation, where a series of statistics are available at an extremely high frame rate of around 2 kHz. In the high resolution mode, the robot perceives its state from a measurement model of training data, where pixel values from the 30 by 30 pixel image are used as features. This is applied to a contour following task where the state consists of angle and radial position relative to the stimulus edge. The perceived state is fed into a proportional controller which enables the robot to follow the edge of a circular shape. The resulting trajectory is shown on the right of this slide. In the high speed mode, we use the image quality statistic as a feature. Here we are simply calibrating contact depth against this statistic. The calibration curve is shown at the top. The robot is then tasked with following a sinusoidal target trajectory and contact depth, shown here in red, and the resulting trajectory is shown in blue. Finally, we came up with a task which required the use of both modalities. The robot was tasked with following the contour of a previously unseen shape, which was also at an unknown depth. The high-speed mode was initially used to modulate the sensor to a depth so that training data from the circular shape would apply. The robot then makes successive taps radially outwards whilst monitoring the image quality statistic until it perceives the edge by threshold crossing. At this point, the robot switches to the high resolution mode and follows the contour according to the procedure described earlier. To conclude, the sensor achieved good accuracy in the contour following and depth control tasks, and this generalized to the non-uniform shape after using the high-speed modality to find the object's height and locate the edge. This is a cost-effective and compact option for dual modality in optical tactile sensors and is an encouraging progression for the field.